Quadratic sequences. This is something we've been looking at throughout this whole year. We've been looking at patterns. We've been looking at sequences during our patterns and sequences unit. We looked at patterns during our quadratic functions unit, and now we're doing quadratic sequences in our quadratic formula or equations unit. All of them are piecing together so nicely. So let's get started. So we have more on quadratic sequences. So we're going to kind of continue on with what we kind of learned yesterday with the square roots and the plus and the minuses. So it says the first three steps of two visual patterns are shown below. The number of tiles in step N of pattern D is defined as this equation, while in step E is defined as this equation. So for each pattern, we're going to decide whether there is a step 176 tiles in it. So we're going to try to see at what step, 5, 6, 12, 45, whatever, how many tiles there will be if it's 167. So what we're going to do on your paper is you're going to write pattern D, pattern D, as in dog, and we're going to write the equation with this 167 tiles in there. So that is actually going to be what our D of N is. That's how many tiles I'm looking for. N is the pattern number I'm going to be looking for. So it looks similar to what we were looking at yesterday, trying to get rid of this squared, or this x or to the power of 2. So I need to take the square root of both sides. Now, I don't know what the heck the square root of 167 is, but let's plug it into our calculator and see. I get 12.922 with a bunch of numbers. So I definitely do not want to write this. I'm actually going to leave it just like this. So what I'm going to leave it as is plus or minus the square root of 167. Because remember, when we square root, we want to put the plus or minus in the front to show that, hey, my answer could be positive or negative. So now I want to get n by itself. In order to get n by itself, I'm going to subtract 3 from both sides. Again, remember, we cannot subtract this combine together this negative 3 and this square root symbol, because those aren't even the same. So we're going to leave it as negative 3 plus or minus the square root of 167, since we don't know what it is. And that's going to be our final answer. Whatever term that is. Obviously, we don't clearly see if it's term or pattern number 6, 7, 12, 14, whatever. So that one will be pretty hard to see when it'll hit 167 tiles. But let's try it for E and see what we get. So we're going to do the same thing. We're going to put 167 in for our E here. And I'm going to set it equal to n plus 1 squared minus 2. Well, the first thing I need to do is get rid of that negative 2 by adding it to both sides. I want to get rid of it because the only thing I need to square root is right here, this n plus 1. So 167 plus 2 is going to give me 169. And I just bring everything else down. Now I can take the square root, meaning I want to cancel out this square by taking the square root. Now I know my square roots pretty well. The square root of 169 is going to be 13 plus or a minus 13 to be exact. The reason why I know that is because, well, I memorized it from 1 to 15. But also I know that 12 times 12 is 144, and I know 14 times 14 is 196, so it's got to be between them. If you don't believe me, plug into your calculator and see. But anyway, what we're going to do to get n by itself is subtract that 1. Now remember, I'm not going to combine it with this 13, this plus or minus 13, because I want 2 answers, it looks like, for this pattern E. So let's see if I can scroll down a little bit. It's okay. I'm going to bring my n down, and essentially I have -1 plus or minus 13. Well, my actual full-blown answers are going to be -1 plus 13, or it could be -1, minus 13. So 13 minus 1 is going to give me 12, and this is going to give me -14, which realistically both are correct answers, but I can't have -14 patterns, so I'm going to have a 12 pattern. So the 12th pattern in this sequence will give me that 167, or a -14, but you know, negative patterns aren't that great. All right, so again, we're going to use the same two equations, but now we're given a different number, 169, to plug in and see if I can figure out if there is an option to these. So pattern D, so essentially I'm going to follow the exact same process. I'm going to set each of my pattern equations set equal to now 169. Hey, I already know what the square root of 169 is, which is a positive or a -13. So hey, look, pattern D might be victorious this time. I'm going to subtract 3. Again, don't combine. We want two different answers. Let's see what they could be. So I have n -3 plus a 13, or -3 minus a 13. Obviously, -16 is going to be one of the pattern numbers, or a positive 10. How nice. Let's see if pattern E is lucky this time around. I get 169 equals n plus 1 squared minus 2. Let's see if we get lucky. If I add 2, like I've done with the other equation, I get 171. Okay, kind of looks promising. Well, let's see if it has a square root, because that's where it all comes down. In order to undo the square, I need to take the square root of both sides. Let's see if we got lucky this time. So 171. Nope, not lucky. So again, if we're not lucky, we're going to leave it as plus or minus the square root of 171. So I get an x plus 1 here. And I'm going to subtract 1. So my final answer for n is -1 plus or minus the square root of 171. Pretty neat, right? Well, these patterns didn't work out, but let's try another 2 patterns and see maybe if we can get something similar. Or actually whole numbers, like in pattern D for B, and pattern E for pattern 1. So it says the number of tiles, that's what our first question is. Our part C now, it says describe and justify the steps of the following. So what I actually need to do is I need to get this x minus h squared by itself. There's actually an a right next to it, meaning it's multiplication. So the opposite of multiplication, and to undo it, is division to get those away. So I'm going to divide both sides by a. And I'm going to be left with k divided by a. And I'm going to leave it like that. Just because I don't have any numbers, that's okay. Take the square root of both sides. What I'm left with when these cancel out is x minus h equals the square root of k over a. And that's totally fine. So far, so good. Oh, forgot my plus and minus. Now, just like with all the other equations, to get x by itself, I'm going to add that h over. So because I want the plus or minus between the numbers so I can figure it out based on if it's a positive or a negative, I'm going to write it like that. I'm going to have k over a. So that's going to be my final answer for that question. Now let's actually get to different parts here. Now I have pattern Q and P. So I'm going to do the exact same process that we've been doing for the other ones, except now I have two different equations. And I'm looking for how many tiles will be in step 399, or sorry, what step number will have 399 tiles. So what I'm going to do is set both of our equations equal to each of their equations. Okay. And now what I'm going to do is I'm going to solve pattern P first, and then I'll deal with Q. Alright, so I want to get n squared by itself. That means I need to get rid of this 2n. I'm actually going to subtract it over. These are not the same. This has an n and this does not have an n. So I have 2n plus 399 or 399 minus 2n, whichever you prefer. And what I need to do to undo a square number squared is take the square root. Woohoo! So what I'm going to actually be left with as my final answer is n equals plus or minus the square root of negative 2n plus 399. Yay! Since 399 is not a perfect square. All right. Let's try Q. So this one's a special case. I need to first get rid of the 14 because that's super duper important. Get rid of the 14 before you do absolutely anything. 9 minus 4 is 5. 9 minus 1 is 8. So I get 385. And all I'm going to do is just take everything down. I'm going to take down this 2, parentheses n squared plus 4n, end parentheses. Now remember that a that we dealt with in the last situation? Well, it's similar to this. I need to get rid of this 2. It's multiplied. The opposite of multiplication is division. So I'm going to take 385 and divide it by 2. I get 192.5. And that is equal to, because these 2 cancels, n squared plus 4n. And I think you can kind of see where this is going, especially when we just did the last one here. I need to get n squared by itself. So I actually need to subtract that 4n. But remember, can't combine it with the 192. That does not have an n. Keep them separate, people. Keep them separate. All right, cancel that out. And take the square root of your final product. And what you get left is n equals plus or minus the square root of 192.5 minus 4n. So this last part here, I'm only going to have a little bit of time to help you start with the first one here. Oh, it looks like I still have part of it. Alright, so for the pattern P, now we're dealing with 134. You just got to subtract that 2n, and you can see that what we're going to get here when we square root both sides is I'm still going to have an n plus or minus 134 minus 2n. The reason why is because this 2 cannot come out yet. That's okay. No worries. And for the last one, you subtract 14, then divide by 2, then you get to get 60, and then you subtract 4n. Remember, these can't be added together. Whoops. And when you square root it, you get a plus or minus the square root of 60 minus 4n. So we will talk more about it tomorrow.